This question 8 is a chi-squared question, and they give you a table of results from 180 spectators at a swimming championship, asking which of the 4 events they prefer to watch. And here are the results. And the first question they want you to do, and this is very typical, write down the null hypothesis. Now, I'll write my hypothesis up here, but you should know this is not an option. Whatever we write is going to be independent. Your null hypothesis is always independent. So then the next question is, well, what is independent from what? And you sort of have 2 ideas here. You're comparing gender with the choice of the event they like to watch. And would it make sense to write that gender is independent of their choice or their preferred swim style, or is their preferred swim style independent of gender? And a quick way to sort of think of this logically is, which of these 2 things do you not get to choose? You don't get to choose your gender, but you do get to choose which swim style you prefer to watch. So the thing you don't get to choose comes over here. So I'm going to write independent of gender. And what is independent of gender? Well, the preferred swim style. You should probably make this a little bit more nice, friendly, saying the preferred swim style is independent of gender, but I'm telling you, just giving you the basics. The key here is the word independent. The IB will allow you to swap these around, although it should make logical sense, and your swim style being independent of your gender makes more sense, but it is, the key is that word independent. So there's part A. Part B, write down the number of degrees of freedom, and the simplest way to do that is there are 2 columns, so take away 1. There are 1, 2, 3, 4 rows, take away 1. What's left over? 1, 2, 3. Your degrees of freedom is equal to 3, and just how did I get that? I actually took the number of rows, which is 4 minus 1, times the number of columns, minus 1, and that equals 3 as well. But when you're given a chart, it's kind of quick just to cross them out and see what's left over. Then let me scroll up to see the rest of the problem. Part C, they want you to write down the value of chi-squared calculated. So we're going to have to do that on our calculator. That'll take a moment. So to use calculator for the chi-squared test, we want to go to matrix, which is second and the x inverse. We edit and type in the number of rows and number of columns, so in this case 4 by 2, and then we're going to enter in the data that we were given. And once we've entered data, it's good just to double check that we've entered the right numbers. And once we've done that, we can now go back to the stats. We'll just exit from there. And we are not calculating something, but actually under the test. And we're going to find the chi-squared test, letter C. And we just scroll down, calculate. And there's our result, 16.42, rounded to 16.4. And notice it also gives you the degrees of freedom if you weren't sure before. So from my calculator, I find out that chi-square calculated turned out to be 16.4. And now, knowing that the critical value is 7.815, state the conclusion of this test. And again, my simple way to remember this is alphabetically calculated before critical, and we write it as a less than sign, so is 16.4 less than 7.815. The answer to that question is no, this is not less than that. Therefore, we're going to be rejecting it. And yes, you can simply say, I reject the null hypothesis because chi-squared calc is greater than chi-squared critical. You could just put the two numbers in. 16.4 is greater than 7.815, or in words. But you have to give this reason, otherwise you do not get the 2 marks. Just saying you reject it with no reason gives you no mark.